Next question we have is our wobble patterns. We have a spot pattern and a line pattern. What circumstances do you see using the spot, and where do you like to use our line?
So just like in the name, the spot is really good for doing small spot welds, but one of our favorite ways to use it, if we're running a longer kind of lap seam weld, we'll put some spot welds all the way down just to prevent that seam from kind of bowing up on itself. So when you're using that, like I said, it's really going to be just for sticking two pieces together and holding it just like a normal spot weld would be for. You're never really going to use it in general welding. It's just not, it doesn't line up well on the wire. You'll have kind of issues with melting the wire completely. So we always stick with the line when we're welding, and when we're doing any type of tacking, spot weld, stuff like that, the dot is a good way to go, especially on those thicker materials. It'll focus the laser a little bit more, give it more punch, and kind of really let it bite in there. So.
And with the line welding for that wobble pattern, that's preferred because you can change the width of that line up to 5 millimeters, so that's just under 1/4 inch. So if you're running a dual 1/16 wire, you can achieve almost 1/4 inch toe-to-toe on that joint.
And kind of another advantage of the line is if you're doing things like outside corner joints, you can increase that line just over those corners, and it'll wash them into the weld, and it'll give you a nice big round flush weld on the corner if that's something that you guys are interested in.
So right now we're showing you the difference between the spot pattern and the line pattern for our wobble graph. As you can see with spot, it is not very accurate and the weld profile is not ideal. Now what you can see is the line pattern. The biggest difference in this is the consistency of that weld and the accuracy. You're having that equidistance toe-to-toe on your weld.
Next question we have is wobble frequency. What does it do? How do you adjust it? And why would you adjust it?
Yeah, so I'll be honest, this is probably my favorite setting. It really seems to have the most impact on your weld besides something like laser power. Standard, the machine is set at 100 hertz, and essentially what that is how fast that laser is moving left to right across that line. When you see the line, it's actually a dot moving left to right 100 times. So you're controlling how fast it's moving across that dot per second. So when we're doing things like dual wire, thicker material, even on aluminum, we generally tend to turn it down to a 45 or a 50. It gives it a little more time to wash that material out, and you'll even find in some cases that it'll actually widen out your weld just a little bit as well. Like I said, just gives it the laser more time to kind of wash that material out. The easiest way for me to think about it is just like a bullet torch. If you have a bullet torch and you're moving it really quick, it's going to heat up your part a little bit slower. If we take that torch and we really let it cook that material and move it real slow, it's going to heat that part up a little bit quicker. So that's kind of my easy mental way of thinking about that wobble frequency.
Yeah, and with the wobble frequency as well, you can get that dialed in, match your wire feed speed to it. You'll have that weave motion, great for outside corners that are a bigger step. Even inside corners that you're trying to just make sure you're getting it to wash in cleanly toe-to-toe.
Yep.
Mainly for dual wire, it's utilized at a lower frequency.
Yep.
I like running at about 30 hertz with the dual wire.
Yeah.
But when doing so, you also have to drop down that wire feed speed.
100%.
If your wire feed speed's moving too fast, now you're going to have almost a zipper-like appearance coming across your filler metal.
Because the wire or the laser can't keep up with how much wire you're putting out. So like James said, it's always a very important thing is, test it, and if you're getting that zigzag across your wire, you're having trouble melting it, either increase your wobble frequency a little bit, or you can drop that wire feed speed just a little bit as well.
So right now we've adjusted our wobble frequency to only 5 hertz. As you can see, that laser is really moving side to side coming out, and that's what's giving us that weld profile and giving us a little more fill toe-to-toe. Now we're set up at 50 hertz on our wobble frequency. As you can tell, there's not as much motion side to side that's visible. It's just moving faster, and with that, you're having a different profile in your weld. Now we have our wobble frequency maxed out at 200 hertz. As you can really see now in this weld, there's so much direct heat into that wire that we're just blowing through this thin aluminum.
Next question we always run across, and it's something that we always notice when we're doing setups with customers. Your wobble size.
Yep.
How does it affect it? Why do we have these ranges set in place so that this way it works, but this way we're not really welding?
Yeah, so an incorrect wobble size can be a detriment to your welding. It'll definitely burn out lenses quicker than you need to. It'll etch out that base material, so it can be a problem. So we always recommend double your wire size. So let's just say you got an 045 that translates to a 1.2 millimeter wire. If we double that, now we have 2.4 millimeters, and that's realistically going to be about your limit for an 045 wire. Like James said, that's one of the biggest issues we see with customers is not knowing what to set it to, kind of how to gauge it and stuff like that. So like I said, my biggest recommendation would be find your wire size, switch it over to millimeters, and then just basically double that number, and that'll give you exactly what your max wobble size is going to be.
And then the same thing with that. That's when you're looking for the max, but you also have that minimum side,
Yep.
which is going to be, if you're running a 1.2 millimeter wire, you're going to want to be right around 1.4.
Yep.
You want to be able to still catch enough base material to get that heat input, but while doing that, you're also going to achieve a greater penetration because now that laser is covering a smaller area.
Yep.
So you're going to have greater heat input control, and that translates right back into wattage and the laser frequency that we discussed earlier for being able to get more out of that 2,000 watt machine.
Yep, 100%.
What circumstances do you find yourself doing that where you're really getting that laser dialed in, you're changing your wobble frequency, and you're running max wattage?
Yeah, so I guess one thing too that I'll bring up that we didn't mention is wobble size can have a good effect on penetration as well. So I'll definitely tighten it up like that when we're going for a max penetration run. If we're doing things like 2 pieces of 1/4 inch and we really need to bite into that material. Another reason would be that if we really kind of want to keep a smaller heat affected zone, even that 2 millimeters can make a large difference on that. Looking at the back side of the plate, it can go from a 1/16 of an inch heat affected zone all the way up to almost a 1/4 inch heat affected zone. So really, your wobble size can, like I said, can have a big effect on that because it's basically how far are we spreading the heat over the material.
So now we've adjusted our wobble size down. We are using 1.6 wire with a wobble size of only 1 millimeter. As you can see, it's a very stringy looking weld profile. So now we're set up with the proper wobble size for the 1/16 wire at 3.2 millimeters. As you can see, the profile of the weld is ideal matched with that wire size. Now we have a wobble size of 5 millimeters. As you can see, it's way too large for the size of the filler metal, and this is what you will be expected to see when you have your wobble size set too large.
And then with that, we'll go into wire feed speed. With the wire feed speed, it is in inches per second.
Yep.
I know that we have our standard baseline that we like to run, but we know what the machine's capable of.
Yeah, this can be another one that's tricky for customers because we don't exactly have a set setting for everything. It is a part of it is kind of personal feel and what do you prefer, and then part of it is we need to match our heat and we need to match how much fill we want. So a big thing could be if you're running really fast, closer to that 1 inch per second area, it will definitely tighten up your weld a little bit. It won't be as wide as it would be if you're running a little bit slower.
And with that, you have that wattage that matches.
Yep.
Can be great for long production runs.
Yep.
Really get that laser moving. You can run probably double the amount of parts.
And once again, it kind of comes down to what do you want as a customer. If you're looking to do stainless and you're not looking to have a ton of holding strength in there, you just want no bluing, you want clean silver welds, then you would want to run a faster wire feed speed with the lower wattage. If you're doing super thick materials, like I said, 2 pieces of 1/4 inch, and you're using a 2,000 watt, then you really would want a slow wire feed speed and a high wattage just to get as much penetration as we could. So it is going to vary from person to person on what you want, but we always say a good starting place is 0.35 inches per second, and then if you want to run faster, increase it maybe 0.5, keep increasing it, and if you notice you're getting a lack of heat a little bit, just increase your wattage a little bit. And just like normal welding, doing a spray MIG or anything like that, you're going to bump up your wire feed, bump up your heat, bump up your wire feed, bump up your heat, and kind of just keep going up and up until you find a place that you're happy with it.
Yeah, and that brings it full circle where everything still translates back to what we're all used to, just different verbiage in it.
Yeah, and one thing with the nature of the laser is you might find too that you prefer a slower wire feed doing an outside corner. It just gives you a little more control. You can see a little bit more what's going on, where you're running a really fast wire speed of 1 inch per second, you're just going to fly through that thing and you might notice you have a little bit of lack of fusion there or here. And like I said, doing certain kind of more critical joints and application, a slower wire feed can definitely be desired. So
yeah, and my go-to when I go out on demonstrations or we have new customers, I like setting them up at a 1/2 inch per second because then you can really feel that wire take over and push your hand,
Yep.
because the wire does control your travel speed.
100%.
So with that, paired with an 045 wire, the customer can really feel the push, feel what that laser is actually doing to produce a quality weld.
100%. Just wanted to go over some of the features and settings on the wire feeder. So you'll notice firstly that we have a knob, which is going to allow you to adjust the number on the screen itself. You're going to have your menu switch, which will allow you to cycle through the different functions. And then you're going to have a wire retract and a wire feed. Starting from the top, we have a delayed feeding. So when you squeeze the trigger, the laser is always going to fire before the wire feeds. There's always going to be a short delay. So this is how you adjust that delay. If you want it longer, slower, if you kind of want to do a hot start, things like that, you can fully play with it and adjust it to how you like it. Under that is going to be your inch feeding speed. So this is going to be your standard wire feed speed control. You want to move faster, you want to move slower, this is how you're going to control that. Under that, we're going to have the retract speed. This is always set at max because we don't want to have to make you turn the knob every time you're going to retract wire or anything like that. So just to make your guys' life easier, this is always set at max, so you won't even have to worry about this one. Below that, we have the inch retract distance. So this is going to be basically how far it retracts at the end of a weld. After each weld with the laser, it will retract the wire a little bit, and like I said, this is just going to be your way to adjust it. Everybody's going to have a different kind of personal preference. Some guys like it more retracted, some guys like it less. So like I said, we give you that adjustability to play with. Under that is going to be your delay filling. This kind of goes hand in hand with that first setting. It's another delay that you can either increase or decrease to your preference. Like I said, it's going to kind of affect how fast you're moving and when you start moving. So once again, it could be used to kind of have a hot start or a cold start, or just kind of keeping it right in the middle. Finally, we have our inch filling distance. This is going to be the stick out on the wire feeding tube. So at the end of your weld, you will notice the wire is going to retract and then stick back out, and this is how you adjust that stick out. Once again, everybody's going to prefer it a little bit different, but if you do dial this in correctly, you can make it so you don't have to sit there and cut your wire every time. We try to keep it pretty simple for you guys, so thanks again.
Next we have dual wire versus single wire.
Yeah, so this is another tricky one. It's always going to depend on what you're looking for, but two, we do want to urge that, you know, if you're looking to run dual 045 wire because you want that size weld, you definitely can just go to a single 1/16 wire. So, you know, not everybody's going to need a dual wire. Another advantage to single wire could be, like I said, going back to the outside corner joint. We see it so much, especially with a lot of the projects we do, kind of electrical boxes, things like that. You know, single wire can follow that groove a lot easier and a lot smaller of a groove. If you get a dual wire and, you know, it's, you know, a 1/16 of an inch wide groove, you know, you probably won't be able to get both wires to sit in there nicely. So definitely dual wire. I do enjoy it for doing those nice big fat welds, T-joints, lap joints, butt joints, all those types of things. But when it comes to those kind of finer applications, those outside corner joints, those inside corners, single wire really can reign supreme on that. So.
Yeah, and both wire feeders have their advantages, have their disadvantages. Dual wire feeder, you're always going to be looking at slower travel speed, regardless. You're running dual 1/16 wire, it's going to take more heat input to be able to melt through that and still achieve penetration.
100%.
With the dual wire as well, your wobble size has to be larger, so you're already going to lose a little bit of penetration due to that double wire size.
Yeah, 100%. And that's one thing we always urge to customers. You know, if you don't need the largest weld possible and you're just looking for penetration, don't even worry about the dual wire feeder. If it's something where you do really need the coverage and you need to meet a minimum weld size, then it's something to start to look into. But like James said, another easy way to think about it is just the more wire we have in front of that laser, the less heat it's going to put into the base material. So it's always kind of comes back to a balance. So
yeah, and with the dual wire feeder and the single wire feeder, there are other settings on there. You have your wire extract speed, your distance. All those are variable per application for what you're doing. They already come preset from us for what our standard is that we like running with single wire or dual wire. And all those really do is, say it's your retract distance, after you terminate the weld, that's how far that wire is going to retract back towards the wire feeder through the liners to have that proper stick out for the start of the next weld.
And just like James said, there's a lot of different settings that you can go through to really dial in that feeder just how you like it. Some guys like more stick out, some guys like less stick out. Once again, bringing it back to kind of just general welding, arc welding, every guy's going to like it a little bit different, and that's kind of what you're going to have to fine tune the machine yourself and see what you prefer. So
and I look at it as your tungsten stick out or your MIG wire stick out when you're starting MIG weld.
Exactly the same. So Now we just wanted to show you guys an example of a single wire weld, and then we're gonna do a dual wire weld on carbon steel. Alright, so we changed over our nozzle, we changed over our feeding block, and now we're gonna run a dual wire weld.